We discussed basic formulas on integration earlier and its application. Now we move a step further and discuss more formulas which are to be used in the subsequent chapters. The first formula in this is prove that integral 1 upon x square minus a square d of x equal to 1 by 2 log of x minus a upon x plus a. And second formula in this case of similar nature, integral dx upon a square minus x square equal to 1 by 2 a log of a plus x upon a minus x plus constant c. Both these formulas of similar nature. If you take up this formula, this is integral dx upon x square minus a square, or this can be written as integral dx upon x minus a into x plus a. We reduce this at this stage as the partial fractions. For this purpose, let 1 upon x minus a into x plus a is equal to a upon x minus a plus b upon x plus a. And if you take the LCM as x minus a into x plus a, this can be written as 1 equal to a into x plus a plus b into x minus a. Now to find the value of a and b here, we put the denominator of a, that is x minus a, equals to 0, the x equal to a. When you put x equal to a here in this say first result, so this is 1 equals to a into a plus a, and the other factor will become 0 because a minus a is 0. So therefore, a equals to 1 by 2a. A plus a will give you 2a. In the same way, for finding the value of b, put the denominator of b to 0. So x equal to minus a. Again substitute in first. So 1 equal to a into 0, because minus a plus a will give you 0, plus b to minus a and minus a, or 1 equals to b to minus 2a, and b equals to 1 upon minus 2a. Now we have to substitute the value of capital A here, 1 by 2a, and capital B minus 1 by 2a. So, coming back to the original problem, so we have reduced 1 by 2a upon x minus a plus minus 1 by 2a upon x plus a and d of x. We can take up 1 by 2a common, integral 1 upon x minus a minus 1 upon x plus a d of x, or this is equals to 1 by 2a. So, integral of 1 upon x is log of x minus a minus log of x plus a plus constant c. Making use of the basic formulas of logarithm, we can write it as 1 by 2a log of x upon a x plus a plus constant c. This is how we do it, this formula. Proceeding in the same way, we can find the integral of dx upon a square minus x square as 1 by 2a log of a plus x over a minus x. The next third formula is integral of 1 by a square plus x square d of x is 1 by a tan inverse x upon a plus c. So, if you take the left hand side, this is integral of 1 upon a square plus x square d of x. Make the substitution, let x equal to a tan of theta. So, dx equal to a secant square theta d of theta. So, this is integral, replace this dx by a secant square theta and d of theta divided by a square plus a square tan square theta. If you take out common, this is a secant square theta d of theta over a square common into 1 plus tan square theta, or this is equal to integral 1 by a. A gets cancelled with a square here. Basic formula of trigonometric is, so this is a gets cancelled with this, 1 plus tan square theta is sec square theta. This gets cancelled with this. So, we have 1 by a integral of d theta. So, is 1 by a theta plus c, integral of d theta is theta. Then from theta, to get the value of theta, we have from here x over a equal to tan theta. So therefore theta equal to tan inverse x over a. So this is finally 1 by a tan inverse x upon a plus c. Now after having derived this result, we next proceed when a square plus x square is under the root. So next result will be for integral dx upon a square plus x square under the root, which is equal to log of x plus under root a square plus x square plus c. We have the fourth formula now, which is integral of dx upon a square plus x square under the root. Well, before we proceed to find its solution, compare the denominator of this with the third formula which we have done. Here in third formula, we have denominator as a square plus x square, but without the root sign. Now here we have the root sign. So we make the same substitution here. Let x equal to a tan theta. So dx equal to a sec square theta d of theta. So integral of dx upon a square common into 1 plus tan square theta, and replace this dx by secant square theta and d of theta under the root. Further, this integral a secant square theta d of theta upon a secant of theta. Note it, here I have made use of the formula, trigonometric formula, 1 plus tan square theta is secant square theta, and square root of secant square theta is secant theta. A gets cancelled with this, secant theta gets cancelled with this. So we have integral secant of theta d theta as formula for integral of secant of theta is log of secant of theta plus tan of theta plus c. Now here we have tan theta equals to, from here, tan theta equals to x upon a. So we change this log as 1 plus tan square theta under the root plus tan of theta plus c. So substitute the value of tan theta here. So we have log of under the root 1 plus x square upon a square plus x upon a plus c. Or this is simplify this, we have log of LCM is a square, so we have under root a square plus x square plus x whole divided by a plus c. Or further, this is log of a square plus x square plus x minus log of a plus c. We have made use of the formula log of m by n. Log of m, this, minus log of n stands for a. Further, log of a square plus x square under the root plus x. For this quantity, both are constant, we can write down another constant c dash. Well, this is a form which we use for integral of dx upon a square plus x square under root. Of similar type, we have integral dx, this is fifth result, x square minus a square under the root, which is log of x plus under root x square minus a square plus c. So consider the left hand side, integral dx upon x square minus a square. Here we make the substitution, here in this case you make the substitution x equal to a secant of theta. So dx stands for a secant of theta tan of theta d of theta. So from here we have secant of theta equal to x upon a. So this is equal to integral, replace this dx by a secant of theta d of theta. In the denominator, instead of x, we have a secant square theta minus a square and square here under the root. Or if you simplify, so this will be a secant of theta d of theta. This is a square common into tan square theta. Here in this case, it is secant theta tan of theta. Make it tan of theta. This is tan of theta here. And square root of this. This is integral a secant theta tan of theta d of theta upon a tan of theta. Here we have made use of the formula that 1 plus tan square theta is secant square theta and tan square theta equal to theta minus 1. So this A gets cancelled with this, tan theta gets cancelled with this. So we have integral of secant theta d of theta, which is equal to integral. So this is equals to log of secant theta plus tan of theta. This is a standard formula, integral of secant of theta plus c. Now put secant of theta equal to x upon a. This is log of secant of theta under root sec square theta minus 1 plus c. This is log of x plus x square minus a square under the root minus log of a plus c. And finally we have, नीचे नहीं आएगा फिर रहने दे, और तू चुप रहा है, ये log of x plus x of a plus c. And finally we can write this result as log of x plus x square minus a square under the root plus some constant c dash. Here we discussed the formulas of integration, but they are similar in nature one way or the other. To remember them, just compare the two formulas and then learn it. For instance, here we have a square plus x square, here also we have a square plus x square. The difference is only the second formula here is under the root sign, but a square plus x square and a square plus x square are same. If it is without root, then this is 1 by a tan inverse x upon a plus c. But if it is under the root, so this is log of x plus a square plus x square under the root plus c. Coming to the other part, where either we have a square minus x square or we have x square minus a square. Now you can further subdivide it like this. Okay, if it is a square minus x square under the root, it is sin inverse x upon a plus c. And if it is a square minus x square without root, then it is 1 by 2a log a plus x over a minus x. Now in the third category here, we have x square minus a square under the root. So its value will be log of x plus under root x square minus a square plus c. And if it is without root, then it is 1 by 2a log of x minus a over x plus a plus c. So now further we make use of these formulas to solve certain problems. So for instance, we have integral of dx upon 9 minus 25 x square under the root. Well, in this case, we have to see which formula we can apply here. I can write the result as integral dx upon 3 square minus 5x square under the root. If you compare with this result, integral dx upon a square minus x square under the root, this is sine inverse x upon a. Instead of a square we have 3 square, and instead of x square we have 5x square. So, this is sine inverse x upon a, that is 5x upon a 3 divided by, note this step, 5, the quotient of x, plus c. See, this is 1 by 5 sine inverse 5x upon 3. This we have discussed somewhere in my early lectures. Okay, integral of dx upon a square minus bx square. Okay, instead of x square we have bx. So, this will be equal to sine inverse bx upon a whole divided by the coefficient of this, of course, plus c. The same I have applied here. Otherwise, you can take out 25 common here and then use this formula so that the coefficient of x square is 1. Well, see the alternative way. This is an integral dx 25 common will be 9.25 minus x square under the root. Now, I am taking the same problem. This 9 minus 25x square, I have taken 25 common. So, I can write down this standard form as 1 by 5 is the square root of 25 dx upon under root 3 upon 5 square of this minus x square. So, which is equal to 1 by 5 sine inverse x upon a, in this case is 3 by 5 plus c, which can be written as 1 by 5 sine inverse 5x upon 3 plus c. In the numerator we have dx upon this. We reduce it to the sum or difference of two squares as 7 minus 6x minus x square. To reduce it as the sum or difference, the x square term must be positive. Take minus 1 common. So, we have x square plus 6x and minus 7. Now, if you combine the first two terms, that is the term of x square and x, to make it a perfect square, we adding square of half of the coefficient of x, that is 6.2 and square of this, which is 9. Adding and subtracting. Adding and subtracting square of half of the coefficient of x, that is 9. So this is minus 1 x square plus 6x plus 9 minus 9 minus 7, or this is equal to minus 1 to x plus 3 and square of this, minus 16 is equal to 4 square. And when you open the bracket, this comes out to be 4 square. This minus and minus will make plus, minus x plus 3 square. I repeat it. Whenever you have to make this a perfect square, you take the coefficient of x, that is, in this case it is 6, divide it by 2, half, and then square. So we added 9 and subtracted 9. If you combine x square and 6x plus 9, it is x plus 3 square. Open the bracket this. So we have the result here, integral dx upon 4 square minus x plus 3 and square of this and under the root. So using the formula that dx upon a square minus x square under the root, which is equal to sine inverse x upon a plus c. So this is equal to sine inverse, for x you write on x plus 3 upon 4 plus c. Likewise, we take up the problem now. Integral, next problem will be x dx, or 1 upon under root x minus a to x minus b and d of x under the root. So we multiply it and becomes integral 1 upon root x square minus a plus b into x plus ab, and of course d of x. Now we want to convert it, this result, the quantity under the radical sign, as the sum or difference of two squares, x square minus a plus b to x plus ab. Adding and subtracting square of half of the coefficient of x, that is a plus b divided by 2, it becomes half and then square it. So, this is x square minus a plus b into x plus a plus b by 2 square minus a plus b by 2 square plus ab. So, this is equal to x minus a plus b by 2 square of this. This will give you x square minus 2ab plus b square. Minus this is a plus b square minus 4ab divided by 4. And finally, this is x minus a plus b by 2 square minus, this is a formula for a minus b square upon 4, or further x minus a plus b by 2 whole square minus a minus b by 2 and square of this. Now, if you replace the result here, so further we shall be using the result here, which is equals to integral of dx upon x minus a plus b by 2, this whole square minus a minus b by 2 whole square under the root, and use the formula here, integral using integral dx upon under root x square minus a square, which is log of x plus under root x square minus a square, of course plus c. So, this is equal to log of x, that is x minus a plus b by 2 minus plus under root x square minus a square, that is x minus a plus b by 2, this square minus a minus b by 2 and square and plus c. And further we can simplify this. It's a very popular question in most of the books. Okay.